Hello everyone, my name is Dr. K.C.H. Apparao, working as an associate professor in Mechanical Engineering Department. In last class, we discussed the question bank discussions mainly on the boiling. In this class, we will see critical thinking questions on condensation. What are the important questions in condensation? So, we will see the film is condensation on vertical wall showing the film thickness, velocity and temperature profiles. What are the assumptions to be considered for analysis of laminar film condensation? We will see different condensation process, classification of the condensation process and phenomena of the condensation process also we will see. We will see first of all introduction of the condensation. The condensation sets in whenever a saturation vapor comes in contact with a surface whose temperature is less than the saturation temperature. Here, surface temperature is less than the saturation temperature. Vapor's temperature, you know that is more than the saturation temperature. So, when this saturated vapors comes in contact with the less surface which has the temperature less than the saturation temperature. So, due to this reason, this vapor will be converted into liquid. So, in the form of the bubbles, we can see here. So, when the saturated vapor comes in contact with the surfaces, so some droplets will be formed on the surfaces due to condensation. Okay. So, as the vapor condenses, latent heat is liberated. Okay. So, there is flow of heat to the surfaces. Those latent heat will be taken by the surfaces, solid surface. So here you can observe here. So this is the vapor. This is the surface which is less than the saturation temperature. Automatically, this vapor is converted into liquid in the form of the just bubbles. Okay. Here also vapor. So more than saturation temperature. So then in contact with the liquid, which is less saturation temperature. Okay, less than the saturation temperature. This vapor is converted into liquid due to condensation. Okay. So here also you can see the next to the liquid condensate may get somewhat subcooled by contact with the cooled surface that may eventually cause more vapor to condense on the exposed surface upon the previously formed condensation. So this is a process of condensation, you can see. So we'll see types of condensations. First one is the film condensation. Next to bubble condensation also we'll see. We know that the term film, which is already covered in the boiling process. Okay. Here, if the condensate tends to wet the surface and thereby forms a liquid film. Okay. Then condensation process, that is nothing but film condensation. So it means those bubbles which are formed on the surfaces due to the condensation, those bubbles mixed with each other and forms a like film, just that covers the surface like this one. Okay. So here the heat from the vapor to the cooling medium is transferred through the film of condensate formed on the surfaces. Okay. The liquid flows down the cooling surface under the action of gravity, and the layer continuously grows in thickness because of newly condensing vapor. So the thickness of this vapor, this is the suppose vertical surface, this is the film condensation will occur. Okay. The continuous film occurs the thermal resistance and the check further transfer of heat transfer in the between the vapor and surfaces. So next the heat transfer, further the heat transfer from the vapor to cooling surface takes place through the film formed on the surfaces. like this one. So bubble to just um, film type. Okay, the heat is transferred from the vapor to the condensate, so formed on the surface by. So this is know that by convection process, it is further transferred from the condensate film to the cooling surface by conduction. Okay, so because the layer which is formed on the condensed layer which is formed on the surface, that acts as a just a solid surface. So due to that layer, conduction also takes place. So here heat transfer takes place from the vapor to solid surface. The latent heat is gives the heat to surface. So by two modes, one is the convection process, another one is the conduction process also. So this combined mode of heat transfer by conduction and convection reduces the rate of heat transfer considerably. Okay, so this is the reason that heat transfer rates of film condensation are lower than the drop phase condensation. Okay, because the thermal conductivity of the this layer, film layer, is less than. So due to that one, heat transfer takes place by conduction is very less. So automatically the heat transfer in film phase conduction is more is less than the drop phase condensation. In drop phase condensation, convection is more and conduction is less. Okay, you know this one. So next one is the drop phase condensation. Okay, so some bubbles are formed on the surfaces due to condensation. In the droplet condensation, the vapor condenses into small liquid droplets of various sizes. Okay, which fall down the surface into random fashion. The drops from these drops form in cracks and pits on the surfaces like this one. Okay, grows in size, break away from the surface, knock off other droplets, and eventually run off the surface without forming a film under influence of the gravity. So due to, suppose if you take the vertical surface, the droplets which are formed on the surfaces eventually gradually increases. So due to the gravity, these droplets are comes into downward direction. Okay, so in this type of condensation, a large portion of the area of the solid surface is directly exposed to vapor without an insulating film. So here you can't see the film formation, only droplets. Okay, droplet condensation have been observed to occur either on highly polished surfaces or on surface maintained. Okay, so here we'll see. This type of condensation gives a coefficient of heat transfer generally 5 to 10 times larger than the film condensation. So we are just observe the differences between the drop phase condensation and film condensation. Although drop phase condensation would be preferred to film phase condensation, yet it is extremely difficult to achieve this or maintenance. So maintaining of droplet condensation is very critical because it is depend upon the surface properties also. So this is because of most surfaces become wetted after being exposed to condensing vapors over a period of time. Okay, so droplet condensation can be obtained under controlled conditions with the help of certain additives to the condensate and the vapor surfaces coating, but its commercial viability has not yet been approved. So it is very critical to form the drop phase condensation. It means maintain the drop phase condensation. So for this reason, so condensing equipment is used. Okay, so these are the just like classifications of the condensation. So film condensation and drop phase condensation. Okay, so we can understand this. Next, we will see some numericals which are related to condensation. This is the vertical plate, 500 mm high. and maintained at a temperature. So the temperature of the plate Ts has been given. Okay, so it is exposed to saturated steam at the atmospheric pressure. So surface temperature is 30 degrees. It is exposed to saturated steam. So this temperature is less than the saturation temperature. So automatically the vapor exposed to this surface, condensation will take place. We know that. And then we have to find out the rate of heat transfer and the condensate rate per hour per meter of the plate. You have to find out this one. So these are the formulas. You know that first heat transfer rate, rate of heat transfer coefficient. So this one is the value, the formula is equal to 0.943 into rho L liquid density into liquid density minus vapor density into thermal conductivity Q into G acceleration due to gravity and enthalpy values by mu L into so length of the vertical plate into T saturation minus solid surface temperature. So by using this one, you can find out the heat transfer coefficient. Okay. If you know the heat transfer coefficient, you can find out the convection process HA into temperature difference T saturation minus T solid. Okay. So by using this formula, you can find out the rate of heat transfer. If you know that rate of heat transfer, you can find out the mass flow rate of vapor. So that is Q by HFG enthalpy. Okay. So in this way, just you can find out. You will see one numerical. So first we have to take the properties of the water film. So you know the temperature, that is the 30 degrees Celsius. At the 30 degrees Celsius, you have to take the properties of the water. Okay. So then density of water, that is the 980. Thermal conductivity of the water, so 66 point this one, and dynamic viscosity 434 into 10 to the power minus 6. And if you know that density and the thermal dynamic viscosity, you can find out the kinematic viscosity also. So enthalpy HFG is equal to 2257. So these are the data we can collect from data book. Next, assume vapor density is very small compared to the condensation process. Okay, so density of vapor is very less the density of the liquid. So length of the plate also given. Next, width also given. So next, temperature of the plate also given, that is 30 degrees Celsius. So you know that the formula, you can substitute all these values. Density of the liquid, so density of vapor is very less. You can just neglect this one. Then the formula is equal to rho L square K cube G into HFC by mu L saturation minus solid surface temperature. So you know all the parameters. Rho is the 980, K is the 66.4 into 10 to the power minus 2, and G 9.81, and HFC so 2257. So if you substitute all the values, you will get the H value. If you know the H value, you can find out the Q value. H bar A into T saturation minus T surface temperature. So this is the formula. By using this one, you can find out the Q value. So this is the rate of heat transfer. If you know the Q, then condensate rate per meter, so mass flow rate of the vapor, so is equal to Q by HFC, you can find out. Okay, so 534.59 into 10 to the power of 10 Q by 2257. So this is the value, mass flow rate of vapor, the value. We'll see one more numerical, then we'll conclude this lecture. Okay, a vertical tube of 60 mm outside diameter. Tube diameter has been given, length of the tube also given. So area we can find out pi dl by this one. Okay, exposure to steam at atmospheric pressure. The outer surface of the tube, so temperature of Ts saturation and surface temperature has been given. So that is 50 degrees Celsius by circulating cold water through the tube. So calculate flowing, the rate of heat transfer to the coolant, and the rate of condensation of steam. Okay, so you have to find this. It means you have to find out the Q and M. So these two values you have to solve this one. For finding Q, you have to find out the H, heat transfer coefficient. So for H, you know that formula, H bar is equal to 1.13 into rho L into rho L minus rho V. So here you can take the properties at 50 degrees Celsius. Okay, so first you can take the properties. So these are the given data: diameter of the pipe, length of the pipe, Ts is equal to 50 degrees. So assuming condensation film is laminar, okay, just where it is in laminar flow. Next, the mean temperatures, the two temperatures are given, you know that one. So saturation temperature of the vapor, that is 100, plus surface temperature is 50, mean temperature is equal to 75. At 75 degrees Celsius, you can take the properties of the water. Then water properties, rho 1 is equal to this one, mu 1, dynamic viscosity, this one, thermal conductivity. Okay, so next to properties of the saturated vapor. So saturated vapor means that is C saturation is equal to 100 degrees Celsius. So vapor properties also you can take. So that is the rho V and HFZ. HFZ is the enthalpy value you can take. So by using this data, you can find out the rate of heat transfer. So rate of heat transfer Q. Okay. So this is the formula. You know that rho L and rho V also, you know that, K also, you know that, G also, you know that, HFG also, you know that. All the data taken from the data book. Okay, yes, you can substitute all this value: mu, dynamic viscosity, length of the pipe, and saturation, T saturation 100, T surface, that is 50 degrees Celsius. You can substitute all the values, then you will get the H value, heat transfer coefficient. Then rate of heat transfer Q is equal to H bar into AS, T saturation minus TS. Okay. If you substitute these values, you will get to rate of heat transfer. If you know the rate of heat transfer, you can find out the mass flow rate. So M is equal to Q by HFZ. By using this formula, you can find out the mass flow rate of the steam. Okay. So the condensation rate is given by M. So Q by HFC. So this is the value. Okay. So let us check, is this laminar flow or turbulent flow? By using the Reynolds number, you know the formula, Reynolds number is equal to 4m by P into dynamic viscosity of the liquid. So if you find this one, this is the value. This is less than the 1800. So this is the laminar flow. So what you have assumed is correct. Okay. So in this way, just you can solve the different numericals which are based on the condensation process. So these are the different textbooks. You can refer these textbooks. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.